Hello everyone, welcome to the Java course. If we are writing some code, we have many chances to compare two primitives. So in this video, we are going to talk about how we compare two primitives, and when we have some conclusion about the comparison, what we are going to do to control the program according to the comparison results. So we will use if and else as the keywords to do some conditional branching of your code. So when one condition is existing, we can do something, or else we do something else. So this kind of conditional statements rely on comparing two primitives. So let us see how we can do the comparisons, and then how we can make use of the comparison results to do different tasks. Okay, this statement is going to compare the values of 1 and 2. Here, 2 equal signs mean that I'm going to check the equality of the literals on the left hand side and on the right hand side. So we know that 1 is not equal to 2, so it is quite sensible to return the word false as the printing result. So let me see. Yes, I will get false because 1 is not equal to 2. So this is known as equality comparison. Here I'm going to do a comparison of two values to check whether 2 is not equal to 1. So the exclamation mark together with an equal sign means that I'm going to check whether they are equal or not. So it is sensible to return false. Let me see. Oh, sorry. It is sensible to return true because 2 is not equal to 1. So this comparison will return a true value. For this one, I'm going to compare whether 3 is smaller than 5. Of course, this is true. According to the greatness of number, we can get the result to be true. Yes, true for this situation. So is 4 larger than 7? If it is larger than 7, I will get true. If it is false, I will get false. So it is easy to see that I will get false. Let me check. Yes, I will get false because 4 is actually smaller than 7. So for the operation here, I'm going to compare whether 2 is larger than or equal to 1. Here, 2 is actually larger than 1, so it satisfies this condition. Yes, I will get true. If I change it to 1, is 1 larger than or equal to 1? Yes, because 1 is equal to 1. So we have to be careful about the main idea or here, okay? We have to check whether one value is larger than another value or whether one value is equal to another value. Let me run it. Yes, I still get true as the answer coming from this comparison. For this one, I'm going to compare 5 with 2 to see whether 5 is smaller than or equal to 2. We will get false for this situation because 5 is actually larger than 2. And of course, 5 is not equal to 2. Yes, I will get false as the answer for this comparison. So after we have learned how to compare two primitives, we can make use of the comparison results to help us do conditional statements by using the if and else statements. We have simple if statements like this. Suppose I have $20,000 of income. If my income is larger than $15,000, I can do something like this. If your income is larger than $15,000, you need to pay more tax. So this statement will be printed out by the print line method here. So if this condition is satisfied, I will do this one. That means I would print the statement out. If my income is not satisfying this condition, I don't do the printing. Let me see. Yes, I will get the result by printing the statement, you need to pay more tax. If I turn the income to just 10,000, I don't see any printing because this condition is not satisfied. We have to bear in mind that the condition has to be put inside a pair of parentheses. This is the syntax of Java. If you miss the parentheses, you can't compile. Let's check. Yes, you will get the syntax error. So we have to add a pair of parentheses like this in order to make the whole condition valid for conditional analysis. For this situation, we don't get any printing, but can we do something like giving another result if this condition is not satisfied? Yes, we can. We can do so by using the else keyword. Suppose I have 6 exams coming up. If the number of exams coming up is larger than 6, you need to spend more time on revision. If I don't satisfy this condition, we can indicate the action by using the else keyword. the revision schedule is not so tight. So 6 is actually not larger than 6. So in this situation, I will print out the else part. Let me check. Yes, I will get the else part. Why? Because 6 is not larger than 6. It is equal to 6. So the if part is not satisfied. If the if part is not satisfied, I will go to the else part to do this printing. So that's the way we use if and else keywords together to do the conditional branching. And we have to notice that when we do the statements following the keyword if and else, it is customary to add a pair of curly brackets to surround the things to be done following the if or else condition. Okay, if we want to set up more complex logic, we can make use of if, else if, and else logic. Let us see an example. The room temperature is now 25 degrees Celsius. If the room temperature is equal to 25 degrees Celsius, the temperature is just good. If the temperature in your room is not 25 degrees Celsius, what should I do? I will go to another part of the conditional branching statements. I will simply say that the room temperature is too high if the room temperature is larger than 25 degrees Celsius. But how about the situation if the room temperature is just, say, 20 degrees Celsius? These two branches are not able to handle the situation. It means that we don't print out anything to indicate the low temperature in your room. In this case, we can make use of one more else keyword to handle all other situations not considered before this else keyword. In this case, I'm going to think about the treatment of the room temperature lower than 25 degrees Celsius. I will say that the temperature is too low in this room. So let me run it to see the result. Yes, the room temperature is exactly equal to 25 degrees Celsius. So the temperature is just good. If I turn it to 28 degrees Celsius, the temperature is too high. If I say just 22 degrees Celsius, I will say that the temperature is too low. If room temperature is equal to 22 degrees Celsius, I don't do the first if part, I don't do the second else if part, I will simply do the final else part. So that's the logic of conditional statements using if, else if, and else together. We can have more complex logic by combining a number of if statements inside an if statement. My age is 18 years old. I'm also a registered voter, so I set a Boolean variable called registered voter to set it to be true. So I'm eligible to vote in the election of my place. If my age is larger than or equal to 18, and if I'm also a registered voter, I can do something like this. I can vote. If I'm 18 years old or larger, but I'm not a registered voter, what should I do? I use the else part to control my further step. Please register as a voter. So we can see the logic again. We first check the age. If your age is already 18 years old or more, we will go to check whether you are a registered voter or not. So this is known as the inner if part. And that one is known as the outer if part. So if the outer part is satisfied, we will go to the inner part to do the checking of your voter status. If your age is less than 18 years old, I don't ever go to the inner if part to check your voter status, because I'm already sure that you are not eligible to vote. So let me run it to see the result. Yes, I can vote because I am 18 years old and I'm a registered voter. But how about when I am just 70 years old? Nothing is printed because I can't even pass the outer if part. If this part is not satisfied, I don't ever go to the inner if part to check my voter status. So if I am 18 years old and my registered voter status is false, what will I get? I will get this statement, please register as a voter. In this case, I can pass the outer if part, but I cannot pass the inner if part. In this situation, I will go to the else part pertaining to the inner if part. So that's the mechanism of nested if statements. I need to handle the outer if part first. If the outer if part is satisfied, I will go to the inner if part. Also, we have to consider the floating point arithmetic issue. It is quite common for Java when we handle some double values whose precision is not always exact. I'm driving now and my car is having a speed of 74.7 kilometers per hour. and the speed limit of the highway I'm driving now is only 70 kilometers per hour. I use 70.0 as the value here because I want to make sure that I'm putting a double value to a double variable name. If my difference between my car speed and the speed limit is exactly equal to 4.7 kilometers per hour, I need to do some printing. If I have speeded up by exactly 4.7 kilometers per hour, I will print this statement like this: speeding of 4.7 kilometers per hour. So in principle, I'm going to print this statement because according to mathematics, 74.7 minus 70 will give me 4.7. But it's able to print it. Let me see. No, I can't. So even though my car is speeding up by 4.7 kilometers per hour, I can't get the printing result. Why? Because floating point numbers are not always exact in floating point representation. What does it mean by that? 74.7 minus 40 might not be exactly equal to 4.7 something. 4.7. If we check the result, I can print it out. Save it, run it. Yes. The floating point arithmetic issue would give the difference 4.7 something, and this trailing part is going to make the result not exactly equal to 4.7 as I wish and as I expect. So in this situation, I'm not able to do the printing. That means the condition is not satisfied. So if we have to consider using some kind of integer as the condition statement inside the parentheses in order to avoid the issue coming from floating point arithmetic. Let me repeat again. The reason is like this. Equality might be false because the floating point numbers are not always exact. So we might have some situation like this. So it is better to use integer as the part of your condition so that you can avoid the floating point number precision issue. And I hope that you're able to make use of if-else or else-if statements to compare your primitives in order to achieve your desired conditional branches. This is the end of the video. If you have any questions about my video, feel free to leave your comments on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.